All right, guys, let's sum up all those rules we've talked about. So first and foremost, how to convert a logarithm to exponential equation. Remember, if you've got log base b of a equal to x, that's equivalent to b to the x equals a. Okay. Remember, logs are exponents. What is x here? It's the exponent on the exponential equation. That's why all of our rules work, because logs literally are exponents. So these two things are equivalent. Make sure you write that part at the top here. So to go from a log to exponential or exponential to log, use this. That's an A, even though it sucks. Now just some basic ones. B to what power is B? 1. B to what power is 1? 0. Doesn't matter what B and is in either of these cases except 0, because you can't really have a base of 0, but yeah, don't worry about that. We're not going to have that. So here's some examples. 14 to what power is 14? 1. 3 to what power is 0? 3 to what power is 1? 0. Product rule. Again, we use this. Let's just sum it up. Then we're going to practice applying them all together. So if it's the arguments being multiplied, we're going to add our exponents, which is, we have logs as our exponents. So log base b of m plus log base b of n. And, just we can go either way on these things. If it says condense, we're going to make it a single logarithm. If it says expand, we're going to break it out as much as possible. So 6 times 7 is 42. The bases are the same, so we can use this rule. If they were not, you could not. So for example, this is log base 5, this is log base 6, couldn't do anything with it. All right, now this one, what times what equals 63? 21 and 3, 7 and 9, whatever you want to do, doesn't matter really. Just get an example. I'm gonna go with 9 and 7. So I could separate this as log base 2 of 9 plus log base 2 of 7. And there are other options. All right, let's check this one out. Same rule as above, except instead of adding, we're going to subtract, because what do we do when we divide our exponents of the same base? We subtract the exponents. Log base b of m minus log base b of n. We're just going to divide those. So you just 84 over 12. Oops, let me go back to 1. 7. So this would be log base 4 of 7. All right, log 9. So that's understood base of 10. We can split this up into whatever the heck we want. How about 90 and 10? Why not? Oh, I'll just leave it there. And we're going to do a minus log of 10. Interestingly enough, if we write it like this, 10 to what power is 10? 1. So this right here is actually 1. So it might be useful at some point in the future. It might not. Just know how to manipulate these rules. You are allowed this cheat sheet on your assessments. Power rule. If we have a power on the argument and come to the front, what do we do when we raise a power to a power? We multiply. So that's all we're doing here. We're multiplying the exponents. So again, we can go either way. If it says condense, you want to get everything inside the log. If it says expand, you want to get it outside of the log. That's going to be log base 3 of 8 squared is 64. This, we're going to use the distributive property, x minus 1 times log base 2 of 6. And if we go further, we distribute that log base 2 of 6. But just applying this property, we're done. Now change the base formula if you have the Casio FX1 5ES Plus, like I told you to. You don't have to worry about it because they have this button right here. If you don't, then you have to use the change of base formula. Change of base formula says log of your argument divided by log of your base is equivalent. So if you have a base of, let's say, 3, well, a lot of calculators don't have a log base 3 button, so you'd have to put log, which is understood log base 10, that's your common log, divided by log of whatever your argument is. Let's see here, we have 32 and 7, so we rewrite this as log of 32 over log of 7. And it can be log of any base. It can be natural log, common log, or even some random log if you really want to. But the only time it would really be useful is if you don't have this button to tell you that log base 7 of 32 is that decimal right there. You could say log of 32 divided by log of 7, and you get that same decimal. Two special bases, log base 10 is the common log, write it like this. There's a base of 10, called the common log. That's spelled correctly. The other one I told you about, ln, that's log with a base of e, and that's the natural log. We're not really going to do with that in this class. Next year we will. All right. So now we're just going to take all those rules and shove them together. Directions condense. It says rewrite into a single logarithm. That means get it all together, condense it. So before I can do anything with the subtraction, I have to take care of the multiplication. I'm going to raise 6 to the second power. Log of 36 minus log of 9. Write out the entire statement. Don't skip around and things. If you do, you will get lost and you will mess up. We're subtracting, so we're going to divide the arguments. 36 divided by 9 is 4. Done. It says simplify if possible, but I'm thinking 10 to what power is 4? Can't tell you. Let's try the next one. On this one, we have variables here, but that's perfectly fine. We know how to apply our rules. Log base 4 of a to the 4th plus log base 4 of b squared. We're adding the logarithms. That means we're multiplying the arguments. Again, we're trying to get it to a single logarithm. Condense it. And we do not mess with our base. Ever. We cannot change our base. Oh, there we go. Same kind of thing on this one. We have log base 4 of u to the 7th. And we have minus, oh wait, we have v squared cubed. What do we do when we raise the power to a power? We multiply. That's log base 4 of u to the 6th. Then we're subtracting, so this is terrible handwriting. This is a u, that's a v. So that's going to be log base 4, that doesn't change. U to the 7th over v to the 6th. I hate using u's and v's at the same time because I often get confused. It's like, oh, is that a u or a v? And then I just combine u's with v's and just messy. That's just me. All right, here we go. We have all, no more powers to worry about up front. They're all nice numbers, so we can just do log base 2. I'll write it out, but you don't have to. 15 times 4, and then we're going to divide by 6. If it's positive, it's in the numerator. If it's negative, it's in the denominator. That's 60 over 6 is 10. All right. Let's see how many of these we got. I might as well do them all. Okay, I'm going to go through these a little quicker. So right here, half power, that's square root of 49 is 7. This is going to be log base 3 of 7. I'll write that down. That's the first thing I need to do. Copy everything else down. Don't forget to write it. If you don't write it, you will get lost. 4 times y is 4y times 7 is 28y. Log base 3 of 28y. Done. This is in parentheses right here. That means the 1/3 goes to both of these guys. So that's going to be the cube root of 8 and the cube root of 27, both of which we should know. That's going to be log base 5 of 8, which cube root of 8, which is 2, plus log base 5 cube root of 27, which is 3, minus log base 5 of 3. Two ways to look at this. I can say it's 2 times 3 divided by 3. Or I can just like, oh, hey, look, these guys cancel. Log base 5 of 2 it is. 4 to the 3rd power is 64. And that's minus log base 2 of 32. So now that we've taken care of our powers, we can go ahead and do the division. 64 divided by 32 is 2. Oh, so that's 1. Log base 2 of 2 to what power is 2? 1. Let's see, no, and no, can't do those, anything with those. That's log of 36, minus, that's the 4th root of 16 is 2. So we have 36 divided by 2 times 3. Excuse me. 36 divided by 2 times 3 is 54. That's log of 54, and no, I can't think of anything that 10 to the raised power is 54, so that's my answer. Okay, now we're going to expand it. Okay, for these, we do the multiplication division first, and then we take the power out. So that's going to be log 6 of x plus, because it's in the numerator, it's going to be positive, log 6 of y plus, it will be log 6 of z to the 4th. Then we're going to use our power rule, and to save time and effort, I'm going to go ahead and just stick that there instead of there. Power rule says the exponent comes out front. Here we're dividing. This is log base 4 of a to the 9th minus log base 4 of b. And again, power rule says that this exponent comes out front. So he's out of there. There we go. Two ways you can look at this one. You can either say, oh, hey, this whole thing's being squared, so that's q to the 8th r to the 4th. Or you can say, oh, the 2 comes out front, so it's going to be other. This way's a little longer, but it's the more obvious. 2 log base 7, and then we split it up. Q to the 4th plus 2 log base 7. That 2's on both of them, right? R squared. All right, we need to get those exponents out front. So that's going to be 8 log 7, log base 7 of q. Sorry. plus 4 log base 7 of r. Same sort of thing here. 2 log base 2 of y minus 2 log base 2 of z to the 5th. This exponent's going to come out here. 5 times 2 is 10. This becomes a 10. Goodbye. All right, 2 more. Remember, radicals are just fractional exponents. This is the 1/2 power. That's the 1/4 power. Yay. So that's half log of 7 plus half log of x to the 3rd. The 3 comes out front. 3 times 1 is 3. And that's it. This one's 1/4 log base 3 m to the 5th plus 1/4 log base 3 of n squared. All right, these guys are both going to come out front. I'll write it on the new step. 5/4, because 5 times 1/4 is 5/4. Log base 3 of n plus 2/4 or a half log base 3 of n. There we go. That is it for properties of logarithms. All right, we're going to stop the video here, and next time we're going to talk about solving logarithm equations.